All right, so I'm going to go ahead and finish up my discussion of section 8.2. This is where we test claims about a proportion. So I want to go ahead and run through the process and then an example. And once again, just to make clear, we're going to use p hat to test claims about p. These claims can often be stated in the notion of a percentage, but any work we do with our calculator needs to be in a decimal or it doesn't work. So a little bit about this first. What I really want to make sure is people understand that we're going to use exclusively the p-value method. Not all the questions in the text say that directly. Some ask you to use, say, tables or perhaps something else. But we really want to use the p-value method with your TI-84 and the one prop Z test. That's what we'll want to make sure we use when we do this test. It's really important. And this one prop Z test can also give you not just the p-value, but the test statistic as well, which means we can use it to find a test statistic, or we could use the formula. And I'll run through one of those too in just a moment. So I now want to just remind you of the actual process. It's a 5-step process. I'm going to be very explicit as I run through the process. I always am. Sometimes I even go 1, 2, 3, 4, 5. But the first step for our hypothesis test is to write the null and the alternative hypothesis. And we'll need to note the initial claim, because I'll need to address that at the very end of the process. That's the first step. The second step is to find the p-value. And that's where I'll use the one prop Z test to do that. Then I will compare with the level of significance alpha. Common values of alpha are 1%, 5%, and 10%. And that is the probability of making a type 1 error where a correct null hypothesis is rejected. Once I've compared my p-value with alpha, I can determine the outcome. And that's where we use reject and fail to reject. Whether it's whatever the null hypothesis happens to be. And then the last notion is to go ahead and address the initial claim. This can be a little bit tricky because that really needs to be addressed in a fairly specific way. I usually offer up a boilerplate sort of sentence, and there's a couple of versions of this out there, but what I usually say is at the blah, whatever it might be, level of significance, data, that's your sample data, and then you have a choice of support, do not support, whatever that initial claim is. And you'll see me write this sentence a couple of different times tonight. The level of significance, the alpha, that'll go right here. Whatever that happens to be, that's where that'll land. So we have the 1, 2, 3, 4, 5 steps for every test of hypothesis. And they all follow that trajectory. What changes from essentially chapter to chapter, or even section to section, as we're seeing here in chapter 8, is what it is we test and the actual tool we use to do the test. But the process of getting a p-value and comparing it to the alpha, determining your outcome and addressing the initial claim, that doesn't change. It just doesn't change. So it's really nice because once you get this down, that process just is always the same. So let me go ahead and take a look at one of these, get this out of the way. Then I'll go ahead and begin my discussion in 8.3. So this is where I'm going to use the p-value method. This is actually one of your homework problems. This is number 10. There is a claim that 3% of Eliquis users, Eliquis is a drug for to control clotting. People who are at risk of stroke use Eliquis. And should have noted the detail there. We're going to use a 5% level of significance to test the claim that 3% of Eliquis users develop nausea. So let me take a look at the data, make sure I get the data in here right, and then we'll take care of that test. So let's see. The number of patients that developed the nausea in this particular problem was 153. The total N in that sample was 5,924. As you can see, samples can be really big. By the way, if you take a close look at your book, there will even be a citation somewhere about where the study came from. This isn't like a made-up problem, like you usually see in a word problem in a math course. This is from the real world. Someone actually did this in the real world. 153 people actually got sick. All right, so there's the question. We're going to test the claim that 3% of Eliquis users develop nausea. All right, so let's run through the drill. The first thing to do is to go ahead and identify the claim, 3% of Eliquis users. So my population proportion P equals 3%. I take a look at that claim. I see that I've got equality in that claim, which tells me what I've got here is a null hypothesis. So I can note, and I'm going to note again on my other sheet when I run out of room here, my null hypothesis is P equals 3%. The complementary hypothesis is P is different from 3%. So what I want to draw from this is a couple of things. I want to make sure I've got my data correct and the type of test I've got going on here. This tells me that my initial claim is my null hypothesis. My type of test here, by looking at the alternative, I can see that it is a two-tailed test. I don't need to write that down. I really just need to note that. In fact, I need to note this and I need to note this. If I forget to come back, that'll be bad. If I can't figure this out, I may not get the right result when I finally reach for my calculator. So let me go through the tedious 5 steps. I'll begin anew. So H naught, P equals 3%. H1 is not equal to 3%. I like colors, so I will note that that's my initial claim. All right, I've got my X and I've got my N. I'm going to jump over to my other seat and pull up my calculator. All right, so stat. When I run over to test, find the one prob z test. My null hypothesis, 0.03, 3%, or perhaps just 0.03, whatever it might be. Puts the 0 in there anyway. That's funny. Sometimes it puts it in, sometimes it takes it out. Wow. How many people got sick? 153 people experienced nausea. 5,924 people were given the drug. We have a two-tailed test. I'll select green, but usually I don't draw my picture. I'm going to run through the process again, and we'll take a look at what draw gives us. But what I need is the p-value. So I've got a p-value of 0. Now, that's kind of unusual, quite honestly. What that means is that this p-value is so small, it's not really 0, but it's incredibly small. It's smaller than my calculator can work with. You'll notice that my sample, see the p-hat there? Literally 0.28 of 1% of the people got nauseous in that study. That is just really, really a lot less than even 3%. So let me stop my sharing.
I think you might have made a typo with the 5,000. It was like 52,000 that you plugged in.
Well, you know what? Thank you for pointing that out. Yeah, it was such a small percent in terms of that. Well, 5,000. Oh, I see. Yeah. Yeah, that might have something to do with it. Let me try that again. Usually they don't pick one that's so just weird for one of the earlier examples. So let's see. There it is. So what did it say it was? 5,924. All right. So now, let me see if I get a different p-value. Fingers crossed. Much more reasonable. So 0.0597. And I got a completely different p-hat that's much closer to 3%. That's 2.58 and change. All right, so 0.0597. I'm going to note that. Let me on pause. Now, the probability, 3 significant digits. Honestly, most of the questions that involve this are multiple choice, so rounding usually isn't a factor. Now, this is where I'm going to need my level of significance. I'll need to compare this with my alpha. The level of significance was 0.05. This is really the big challenge that my students face. If you're good and you're comfortable with inequalities, then this stuff is a true breeze. But if they do challenge, then this can be a challenge. So, which one is bigger? This guy is bigger than that guy. So, at that point, I need to remember what to do with my outcomes. So let me run through that p-value again, what the outcomes were. If p is less than or equal to alpha, we reject the null hypothesis. If p is greater than alpha, it is a fail to reject the null hypothesis. By the way, this is supposed to be a capital P. Your calculator should be showing you a capital P, but apparently it's just incapable of that level of detail. So that tells me what I need to do. So I will go ahead and I will reject the null hypothesis. So that's 1, 2, 3, 4. Now, what we need to do is to determine if the initial claim was supported or not. So, was that initial claim supported? The initial claim was this guy right here, the initial claim. What was our outcome? we rejected H naught. So the actual outcome was the alternative hypothesis. So the data did not support that initial claim. So at alpha equals 5%, data do not support, and then I just state that initial claim, P equals 3%. Oh boy, I'm backwards. You're about to say something, I can tell. It's greater than. Boy, what am I thinking? And to reject H. Okay, let me try that once again. I apologize. So that's the initial claim. That's also the outcome. So the data do support. And now I'll just run through that again. And this time I'll say P equals 3%. I'm sorry about that. We got another one coming up. Hopefully I won't make that same mistake again. But at the end of the day, this is where the test is really determined. Now, here's the thing about the p-value and the level of significance. So let me grab a fresh sheet here and just note that, and I will ask questions about this. We bring the level of significance. Yeah, it's stated in every problem, but it's the researcher who decides what to use, or the person interpreting data who decides what to use. There's no real golden standard here. So for example, in that last problem that we just did, we had a p-value of 0.0, what was it, 597. And our alpha was 5%. Or 0.05. 0.0597 is greater than the 0.05, which means we fail to reject the null hypothesis. But suppose we change things. Suppose we say alpha is going to be 10% instead of 5%. So that's now 0.10. And when I take a look now at my p-value of 0.0597, now my p-value is less than my level of significance. So now we would reject our null hypothesis. So I'm not asking you to use multiple levels of significance in any problem unless you're specifically requested to do so. Every problem will come with its own level of significance in terms of a test of hypothesis. But you got to realize that if you change your alpha, you possibly change the outcome. Remember, alpha is the bar for rejecting a true null hypothesis. So when we go from 5% to 10% on the alpha, we essentially make it easier to reject the null hypothesis. In the court case analogy, that would be easier to convict an innocent person. So there's that. That's really important, and I want you to remember that. There's a couple of questions, especially on the reviews, and I think in the homework too, that ask you to change the alpha and then reinterpret the outcome, because it's the alpha that we bring to the process that matters. And it's not set in stone. It's not. In fact, in most professional research publications, they don't even give you an alpha. They just give you the p-value. They might say, oh, the p-value is less than 0.01, or it's less than 0.001, or something like that. Or they may just give you the value, let you decide whether you want to use a 5%, a 10%, a 1%, whatever the case might be. So for tests about a proportion, there's a couple of things that you'll really need to be required to do. You'll really need to be required to conduct such a test that you just saw me do. With the TI-84 using that one prop Z test and a p-value. I also want you to be able to calculate a test statistic. You could run into either of these types of problems on quizzes and exams. And I'll remind you that test statistic is Z equals P hat minus P. And then down below, we got the P, the Q, the N that lives in the radical. And there's two ways of going about doing it. One way is to just go ahead and use the formula directly. You'll remember that P and Q come to us from H naught and H1, and P hat and N come to us from our sample. And if I ask you to find a test statistic, I would give you all of this information. Let me show you that you can get the test statistic both ways. I've already done it this way. I want to run through the keystrokes there one more time. And then I also want to show you how you can use the one prop Z test to get the same test statistic. So here's data. Claim P equals, oh, I don't know, 75%. I'm making this up on the fly. We have some data. X is equal to 79 and N is equal to 100. There's my claim. By the way, I'll note that that is the null hypothesis, P equals 75%. So if I want to find the test statistic, I can go ahead and use the formula. By the way, if P is equal to 75%, Q is equal to 25%, because those two have to sum to 1 or 100%. So my test statistic, Z is equal to P hat, 79 out of 100, 0.79, minus 0.75, that's P. Downstairs in the radical, 0.75, 0.25, divided by my sample size of, it was 100. So, many people will remember the formula. The book is, or excuse me, the exams and quizzes are open notes and open books. People might just run to the formula just because that's it's a comfortable thing to do, but it can work. So let me go ahead and share my screen. Take care of that little guy. Clear. Now, 0.79 minus 0.75. I can do everything in one set of keystrokes, but I really like to take care of the numerator first. Then I can divide the result by, and my order of operations is, oh, sorry, that's not right. And the order of operations takes care of itself. So there we go. So we got 0.75 times 0.25 divided by 100. That's in my radical. So there we go. So 0.924. All right, so that's clearly one way of going about doing this problem, but I can also take care of this right at the one prop z test. The null hypothesis was 0.75. X was 79, N was 100, and we had a two-tailed test. Honestly, the tail of the test doesn't matter here because that's what you use to calculate your p-value, not your test statistic. So go ahead and draw if you want, but there you go. There's the z equals 0.9237. So there's a couple of different ways of going about doing this. As I say, the formula isn't overly difficult to use. Everything you need for your formula, I'll point out, except for Q, you also need for your test. So I can use the test statistic formula, or I can use the one prop z test. Either one works, and I leave it up to students to determine which is which. All right. So that brings me to the end of my 8.2 discussion. So I'm going to go ahead and stop my video.